Okay, now we're given three polynomials and we're asked to show their basis for P2. So once again, we got to go to linear independence. We got to look at a linear combination of these guys. And see what values of C1, C2, and C3 are there so that this is equal to the zero vector. Well, the zero vector in P2 is a zero polynomial, 0. This is going to give rise to a system of equations for C1, C2, and C3 by equating the coefficients of t on either side of the equation. So if I look at the coefficient of t squared, I'm going to get negative C1 plus 2c2 plus 5c3. That has to be the coefficient of t squared on the right-hand side, which is 0. For t now, I get no contribution of t here. Here I get 1c2t. No contribution there. I just get 0. And then I look at the constant terms. Here I'm going to have 3c1. Here I'm going to get minus 4c2, and then 7c3. Does this system of equations look familiar to you? It should. If you write it in matrix form, the matrix A you get is the exact same coefficient matrix we had in the previous problem. So, by our work in number 1, we know the determinant of A is not 0, which means that AX equals 0 has only the trivial solution, which is exactly what we needed to show for linear independence. So, you know, if I just write down these coefficients, right? It's as if I'm just looking at the same vectors I had before. Right? So I'm just writing down the coefficient of t squared in the first component, the coefficient of t in the second component, and the constant term in the third component. Those are the exact same vectors. So in some sense, the polynomials in these vectors, as far as the vector spaces themselves are concerned, are pretty much interchangeable. As far as spanning goes, well, I'll get you started, but you can see I take a generic element of P2, this might as well be looking at a linear combination of these vectors being this vector. And so our work before shows spanning. So the fact that these three vectors span R3 gives us the fact that these three polynomials span P2. And so there's something deep there, and we'll be talking about that as we move on. But if you get the system of equations and check the matrix, everything's going to happen like it did before. That'll do it for Quiz 8.